Okay, 9.3 day 4, we're using the unit circle again. Okay, so to remind you, this is the unit circle has a radius of 1, which means these ordered pairs on the corner are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And I keep labeling them because they're important. This is 0, this is pi over 2, this is pi, this is 3 pi over 2. Okay, just like last class, the sign of pi is the y-coordinate of the ordered pair on the unit circle. The cosine is the x-coordinate. Tangent is y over x. Now, we did not do the reciprocal functions last time, but we know which one is reciprocal of which. So cosecant is the reciprocal of sine. So cosecant is 1 over y on the unit circle. Secant is 1 over x. And tangent is x over y. Or we just flip the answer we have. Okay, so we're going to keep using the unit circle to evaluate, but now we're just going to add in some of the reciprocal functions. Okay, let's look at the unit circle real quick. Okay, so example 1, use the unit circle to evaluate the indicated trig function. So I'm doing sine of pi over 6. Let's look at pi over 6, keeping in mind that sine is the y-coordinate of the pi over 6. Okay, tangent of pi over 6 is going to be y over x. Okay, what's y? Oh, I just got y. Y was 1/2. What's x? X is root 3 over 2. Flip back to your circle real quick and look. Okay, let's simplify this. And some of you have gotten used to it enough that you can simplify it a little faster. The 2's cancel. So I'm left with 1 over root 3. And then if I rationalize that, I get root 3 over 3. Okay, now what's cosecant of pi over 6? Cosecant is the reciprocal of the sine. Since I happen to know the sine is 1/2, I can flip it to get the cosecant. So instead of 1 over 2, this is going to be 2 over 1, which is 2. Or I could look at the y-coordinate and I can flip the y-coordinate. Okay, the next row, what do we got? 3 pi over 4, so cosine of 3 pi over 4. 3 pi over 4, cosine is the x-coordinate. Let's look at 3 pi over 4. So the cosine of 3 pi over 4 is negative root 2 over 2. Cotangent, what's cotangent? Well, tangent's y over x, so cotangent is x over y. I know the x is negative root 2 over 2 because I just used it on the last problem. If you look at the y-coordinate is positive root 2 over 2. Okay, what cancels? 2's cancel, root 2's cancels. What's left? Just the negative. So the cotangent of 3 pi over 4 is negative 1. Okay, the secant of 3 pi over 4. Secant's a reciprocal of cosine, so I want to flip the x. Do I know the x? The x is negative root 2 over 2. So secant is going to be flipped. And it doesn't matter if you put the negative on the top or the bottom. But I can't leave the radical at the bottom, so let's rationalize this. Okay, if I rationalize this, I multiply by root 2 over 2. So I get 2 root 2 over negative 2, which is good, but now I can see I can cancel out the 2's. So if I do root 2 divided by a negative, I get negative root 2. So the secant of 3 pi over 4 is negative root 2. Okay, let's try the next one. So we got tangent of 2 pi over 3. Tangent is y over x. Let's look at my circle for 2 pi over 3. Okay, root 3 over 2 over negative 1/2. What cancels? The 2's cancel. And then what do I have? I have root 3 divided by negative 1, which is negative root 3. Okay, cosecant. Cosecant's the reciprocal of sine. Sine is the y. So I want to do the y and I want to flip it. Let's look at the y and then flip it. Okay, can I leave it like that? No, I'm going to rationalize it. So I get 2 root 3 over 3. Okay, now secant. Secant is the reciprocal of cosine, so I want to do the x-coordinate and flip it. Let's look at the x-coordinate. So if I flip negative 1/2, I get negative 2 over 1, which is going to be negative 2. Okay, how about the cosine of pi? Well, hopefully some of you recognize pi. It's negative 1, 0, but let's look. So cosine of pi is negative 1. Okay, secant is the reciprocal of cosine. Okay, so 1 over negative 1, which is also negative 1. Okay, the sine of pi, the sine is the y-coordinate. It was negative 1, 0, so that's going to be 0. Okay, cosecant is the reciprocal of sine. So sine is 0, so the reciprocal is 1 over 0. Oh, we're not allowed to divide by 0. So this is undefined. Okay, 0 on the bottom is always bad. Okay, tangent of pi is the y over the x. Hold on, I forgot. Let's check. Okay, 0 divided by negative 1, that's 0. Okay, cotangent, instead of 0 over negative 1, it's going to be flipped. Negative 1 over 0. What is negative 1 divided by 0? Undefined. Try it on your calculator. It's going to give you an error because your calculator is sometimes smart. Okay, on the back of your paper, there's a unit circle. The unit circle has somehow mushed into one unit circle instead of two. You can reference whichever unit circle you have, but this is sometimes we combine it into one since it is the same circle. Okay, if I look at this, I'm just going to show you. This is still the corners. Boom, 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 boom. This is pi over 4 still. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and then the 6's are right here. We're going to try to use both at the same time. Okay, pi over 6 is right here. The y-coordinate is 1/2. Okay, pi over 4's are right in the middle, so 1 pi over 4, 2 pi over 4. There's 3 pi over 4. It's negative root 2 over 2, root 2 over 2. So the x-coordinate is negative root 2 over 2. Pi over 3, 1 pi over 3, 2 pi over 3. So y over x, root 3 over 2 over negative 1/2. 2 pi over 3. The y-coordinate's root 3 over 2, so flip it, 2 over root 3. 2 pi over 3, the x-coordinate is negative 1/2. Okay, pi is right here. Coordinate's negative 1, 0. The x is negative 1. Okay, y over x. So 0 divided by negative 1. Okay, last example. We're going to use the unit circle to evaluate coterminal angles. And those are going to be angles that are not on our circle, but they are on our circle if we graph them out in standard position. So we're going to start out with the cosine of 6 pi. I know cosine is the x-coordinate, but 6 pi is not really on my circle, but we can figure it out. Okay, let me start from 0. Where is 1 pi? 1 pi is right here. I want to go 6 pi. Let me start again. So this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So if I go 6 pi, I actually end up way back at 0. Okay, so now let me answer the questions about the cosine of 6 pi. Cosine is the x-coordinate, so 1. Okay, let's do the sine of 3 pi. Okay, 3 pi is not on my circle, but 1 pi is, so I can figure this out. This is 0. 1 pi, 2 pi, 3 pi. So 3 pi is the same as pi, or it's coterminal pi. The sine is the y-coordinate, so the sine is going to be 0. Okay, how about 7 pi over 2? 7 pi over 2 is not on my circle, but pi over 2 is. So from 0, this is 1 pi over 2. 2 pi over 2. 3 pi over 2, which matches. 4 pi over 2. 5 pi over 2. 6 pi over 2. 7 pi over 2. So 7 pi over 2 is coterminal with 3 pi over 2. What am I finding? The sine. The sine is the y-coordinate, so this is negative 1. Okay, let's do the cosine of 5 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2, which matches up, so I'm on the right track. 4 pi over 2. 5 pi over 2. Okay, so 5 pi over 2 is coterminal with pi over 2. The cosine is the x-coordinate, so that is 0. Okay, how about negative pi over 2? Okay, I know that if I go from here to here, I go to positive pi over 2. If I'm going negative, I'm going to go backwards. I still have to start from 0, but instead of going up pi over 2, I'm going to go down pi over 2. So negative pi over 2 is down here. The cosine there is 0. Okay, now let's look at the 4's. Okay, 9 pi over 4 is not on my circle, but there are other pi over 4's on my circle, so I can use them to figure out what 9 pi over 4 is. Okay, I'm going to start from 0 always. This is 1 pi over 4. This distance is a pi over 4. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4 is going to be up here. And some people get to 8 pi over 4 and they go, I only have one more to go. Okay, what am I finding? The sine. The sine is the y coordinate, so that's going to be root 2 over 2. Okay, what do we? 11 pi over 4. Okay, let's count the pi over 4s again. 1, 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Some people are like, I only have 3 more. I'm going to go here. Great. Or you can count it. 9 pi over 4, 10 pi over 4, 11 pi over 4. Okay, so I end up over here. What am I trying to find? Cosine. Cosine is the x-coordinate. The x-coordinate there is negative root 2 over 2. Okay, we're getting there. Uh-oh, we got a 6. Okay, 17 pi over 6 is not in our circle, but 1 pi over 6 is. It's right here. And I need to remember that this is 1 pi over 6. And I'm going to count that 17 times. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And this tells me I'm on the right track because it matches. 6 pi over 6, 7 pi over 6, still on the right track. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, still doing good. 12 pi over 6. Now once you get to 12 pi over 6, some people go, okay, no, to get to 17, I just need 5 more, and then they cut across here. I'm going to count it, but you could also do that. 13, 14. Oh, I lost count. What was that? 12, 13, 14, 15, 16, 17. Okay, so I end up way over here. And what am I looking for? The sine. Sine is the y coordinate, so the y coordinate there is 1/2. Okay, let's do the cosine of negative 5 pi over 6. Okay, 5 pi over 6 is over here. Negative is go backwards. So I'm going to go backwards that same distance. 1, 2, 3, 4, 5 pi over 6. And I'm going to end up over there. Okay, the cosine is the x-coordinate. So the x-coordinate there is negative root 3 over 2. Okay, a couple more. We're going to go by 3's now. Okay, 7 pi over 3. Okay, where's 1 pi over 3? We're almost done. 1 pi over 3 is right here. So this is a pi over 3, so be careful. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So I'm at 6 pi over 3, so one more and I get to 7 pi over 3. So 7 pi over 3 is right here. Sine is the y-coordinate, so that's going to be root 3 over 2. Okay, 11 pi over 3. Okay, 1, 2, 3, 4, 5, 6. Or if you remember this was 6 pi over 3, you could keep going. Okay, from here, 6 pi over 3. Some people go, well, I have to go 5 pi over 3 more. I'm going to end up here. I'm going to count it. But if you see that, you can go ahead and write your answer. 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3 is going to end up way over here at 5 pi over 3 because they're coterminal. That cosine is the x-coordinate, so this is 1/2. Okay, last one. Sine of negative 4 pi over 3. Okay, if I go pi over 3, I go this. If I go negative pi over 3, I go this way. 1, 2, 3, 4. So I end up over here. The sine is the y-coordinate, so that's going to be root 3 over 2.